Welcome to Lesson 6.4, Conducting Security Testing, Target Identification. In your Candidate Information Bulletin, we are in the Security Assessment and Testing domain. We are in Key Area of Knowledge B, which is Conduct Security Control Testing, and D, which is Analyze and Report Test Output. Our topics are going to include testing techniques, target identification and analysis, active network discovery, port and service identification, vulnerability scanning, passive and active wireless scanning. Technical security testing techniques can be divided into two primary categories: target identification and analysis, the objective of which is to identify systems, ports, services, and potential vulnerabilities, and target vulnerability validation, the objective of which is to corroborate the existence of vulnerabilities and, as applicable, provide proof of concept exploit. Now, in the last lesson, we talked about examination, which was passive. In this lesson and in the next three, we're going to be talking about actual testing techniques. Testing is active and testing can be intrusive. So the first one we're going to be looking at here is target identification techniques. And the objective of target identification, again, is to identify and enumerate systems, ports, services, and potential vulnerabilities. Our techniques include active network discovery, network port and service identification, vulnerability scanning, and wireless scanning. The objective of active network discovery is to identify active and responding devices on the network, as well as to identify rogue or unauthorized devices. Active techniques include using the ICMP protocol to ping, to issue the ping command to see what devices respond, and to use the ICMP protocol for OS fingerprinting. Now, OS fingerprinting is when we infer an operating system based on TCP/IP attributes, such as the initial packet size, the initial time to live, or TTL, the window size, and the maximum segment size. Now, caution, when you're doing active network discovery, there may be an impact on bandwidth, and the volume of alerts may be generated if you're using alerts either on your firewall or even IDS or IPS system. The objective of network port and service identification is to identify listening network ports and corresponding services and applications. Network port and service identification requires the use of scanning techniques. Now, scans can be configured to either target a single IP address or an IP range, or check for specific UDP or TCP ports or ranges. Scans can also be configured to check for banners, often referred to as banner grabbing. Your scans can also be configured to operate at different rates of speed, from very fast to very stealthy. You may need to adjust the rate of speed depending upon when it trips an IDS or an IPS alert. Your cautions here, again, that you may impact bandwidth and the volume of alerts that may be generated during scanning. Vulnerability scanning is the process of identifying host attributes, outdated software versions, missing patches, misconfigurations, security policies, known CVEs, or standard deviations. In other words, the objective of vulnerability scanning is to identify weaknesses or vulnerabilities in your system. Vulnerability scans can check compliance with known surface vulnerabilities. The surface vulnerabilities are vulnerabilities in isolation. Surface vulnerabilities do not take into consideration defense in depth, layered controls, or any types of mitigating controls. It's just specific to what that target is. Vulnerability scans often may provide guidance on vulnerability mitigation, and our cautions here include the required use of privileged credentials for authenticated scans, because our vulnerability scans can generally run in two modes, authenticated and unauthenticated. Authenticated is going to give us much better visibility, but now we're also operating in a privileged mode. We may use a lot of bandwidth up, so bandwidth utilization. There can be an impact on host performance. We may trip a number of IDS alerts, and it's very important when you're vulnerability scanning that you keep updated signatures and plugins, because your vulnerability scanner needs to know again, about the latest CVEs, about the latest patch levels, about the latest versions, software versions. So keeping your vulnerability scanning updated with signatures and plugins. So let's just take a look at a wired network, and let's look at sort of our identification and analysis building block. What's the difference between the three different techniques that we looked at? So we've got our wired network again. We're saying, let's try each one of these. So our first technique was network discovery. The outcome of our network discovery, right, we're just using a ping command or we're doing OS fingerprinting, is to discover active devices and, of course, rogue or unauthorized devices, and that will facilitate a network map. By what responds to us allows us to build a map. Now, the caveat is if a system isn't on the network right then or the system is turned off, it's not going to respond. Network port and service identification discovers our active devices, can also facilitate mapping, but then discovers open ports and associated services and apps. Remember, a port was really just an identification for a listening service or app. So depending on what port they're listening on, that generally tells us, particularly if they're a well-known port, right, the 1 to 1023s, what we should expect for an associated service or application. Going up a layer, the vulnerability scan can discover active devices, can facilitate network mapping, can discover open ports and associated services and application, but builds on that by identifying known vulnerabilities and may also provide mitigation recommendations. As we go from discovery to port and service identification to vulnerability scanning, we've got increasing complexity, we have increasing use of bandwidth, and the potential that we'll trip IDSs or other alarms. If we move over to the wireless environment, we have two different types of scanning. We have passive and we have active. The objective of passive wireless scanning is to capture wireless packets to identify key attributes and discover rogue devices. Our passive wireless scanning can reveal the service set identifier, or the SSID. So is the wireless network broadcasting its existence and what name is it using? Device types and MAC addresses of devices or access points that are on the network, the channel and the signal strength, and the number of packets transmitted. Our cautions here including dwell time and antenna range. So how long are we going to have to be on the wireless network in order to be able to get this information? And then we're going to be limited by the range of our antenna. The objective of active wireless scanning is to identify vulnerabilities and security configurations, including authentication requirements, data encryption, and administration. So an active wireless scan can identify available connections, can attempt to connect to access points and client devices that are on that network, can capture and then attempt to crack the data packets. And generally that's done in an offline mode. So the packets are captured and then they're run through cracking programs offline. Our cautions here include dwell time. How long would you have to be on a wireless network to actually capture all of the devices? The antenna range and privacy, because here we're going to be looking at client devices and potentially get into client devices and also into data packets. There's always a chance on a wireless network that there are either unauthorized devices or devices that have inadvertently connected to that network, or you as a scanner have inadvertently connected to another network. Active wireless scanning really is sort of a pen test crossover, and we're going to be talking about penetration testing. So active wireless scanning kind of falls in this middle ground between really just doing network discovery and actually moving into the realm of penetration testing. So a wireless scanning comparison between passive and active. Our passive discovers wireless signals. It identifies authorized and unauthorized wireless devices within the range of the scanner. It's really doing our discovery and mapping. Our active can discover wireless signals. It can identify authorized and unauthorized wireless devices within range of the scanner, so same as our passive. It can identify authentication requirements. It can attempt to identify access points and wireless device settings, and it can attempt to crack encrypted packets. That brings us to the end of Lesson 6.4. In Lesson 6.4, we talked about various testing techniques. We focused this lesson on target identification and analysis. We looked at active network discovery so that we could see what devices, both legitimate and rogue, were on our network. We looked at port and service identification So we could take it a step further and say not just what devices, but what services or applications are these devices running by inferring from the ports. We looked at vulnerability scanning, took it a step further, and said, okay, for these devices, what might their weaknesses be, including misconfigurations, known CVEs, missing patches, or anything else that we could identify that might be problematic about the target devices. Then we looked at passive and active wireless scanning, passive scanning being more analogous to our active network discovery. Our active wireless scanning is really closer to vulnerability scanning with a crossover into penetration testing. So that brings us to our 6.4, match the meaning. The terms I want you to be able to match up are port, vulnerability, ICMP, OS fingerprinting, a banner, a surface vulnerability, rogue, and MAC. Go right ahead, put me on pause, take some time, match up the meaning, then come on back. All right, let's go through lesson 6.4 terms. A port is an application identifier. Remember, we have our well-known ports, which is 1 to 1,023, but there's actually in excess of 65,000 ports available. A vulnerability is a weakness. ICMP is an internet layer IP protocol. OS fingerprinting is when we infer the operating system by TCP/IP attributes. A banner displays our application type and version. A surface vulnerability is a weakness that exists in isolation, not taking into account any other mitigating controls or defense in depth or layered control techniques. Rogue refers to unauthorized. And a MAC in this case is a network interface card. That's going to be the MAC address of the card. Remember, we use the ARP protocol to do our IP to MAC translation. So before it's not mandatory access control in this case, it refers to the network interface card identifier. So we're going to end lesson 6.4 with our CISSP exam tips. Our first tip is that scanning 65,535 ports across multiple network devices will most certainly cause degradation. So you need to scope out what your scanning is going to be. Our second is that effective vulnerability scanning does require continual software updates or plugins so that our scanning software knows about the most current vulnerabilities. The third is that privacy issues must be considered when designing wireless testing and examination. So thanks for joining me for this lesson, and I look forward to seeing you in the next.